Hello, let's see this. These are the two given functions to us. Fx equals to square root of x plus 1 minus 1 and gx equals to x plus 1 whole square minus 1. Now we have to find whether these are inverse of each other or not. Well, this question is asked in thinking and communication problems, and first let's analyze it. Okay, let's make a kind of rough sketch. Now if you're talking about this function, then this is a square root function, correct? And the transformation is that you have moved it 1 unit to left and 1 unit down. So the basic square root function is like this. This has been transformed 1 unit left and 1 unit down. So you get a function like this. And how about this? This is a parabola. And the domain of this parabola is all real numbers. This function is also moved 1 unit left and 1 unit down. So it also starts from here, and so parabola will go like this, kind of like this. Now the question is whether they are inverse of each other or not. Truly speaking, they cannot be, because this has got a domain and range of only x greater than or equal to minus 1, and its inverse could be one part of this, that is this portion of the right. But how about this part? That cannot be. If we do inverse of this function, then that should have plus and minus of this, correct? So the answer is they are not inverse of each other. Now that is how you can explain that they are not inverse of each other. Now how can we restrict the domain of the function so that they can be inverse of each other? That's the second part of the question. Now, well, if you look into the square root function, then the domain of square root function is what? Is x is greater than or equal to minus 1. Because x plus 1 should always be positive. If we take a value on left side of minus 1, that will become negative, right? So x plus 1 greater than or equal to 0 gives us that x belongs to all real numbers where x is greater than or equal to minus 1. Now that makes sense. From our rough sketch, this is at minus 1, and it seems that the inverse of this function is actually this function, and inverse of this function is also this function. So they are inverse of each other if we restrict the domain to x greater than or equal to minus 1. So here also we will consider x greater than or equal to minus 1. In that case, we are talking about only the green function, which is square root, and one arm of our square function. Okay. So this is one way we can do it. We have a graph paper, we can plot it, and then we will see that if we draw a line x equals to y, then the green portion fx can be reflected on gx, and they're symmetric about the line x equals to y. So that part we can do, right? So let's do it quickly. Now we can draw the function here. Our basic function is, let's draw it, fx. So let me draw fx equals to square root of x plus 1 minus 1. So original function, let me draw the original function. We can take this, I'm drawing square root x, okay? So 0, 0, 1, 1, and square root of 4 is 2. So 1, 2, 3, 4, and 2. So these, we'll just take these 3 points for the time being, and just like this, right? If I transform it, that is, I have to bring it to left 1 unit and down 1 unit, each point. So I'm bringing this 1 left and 1 down. So it comes here. The second one, 1 left, 1 down, comes here. The third one, 1 left, 1 down, comes here. Yeah, so we got these 3 points, right? Let me join with this blue ink. This is our function fx, and this one was just square root x, correct? Yes. Now let's draw the transform function x plus 1. So we see normally that function, let me write here, gx equals to x plus 1 whole square minus 1. So initial function we're only assuming that restricted domain is x is greater than or equal to minus 1. Okay. Now initial function, so we'll take just the one arm of initial function, which is x squared. So that is 1 point, 1 and 1. And at 2, it is 4. So 1, 2, 3, 4. Correct? Now if I transform these points, 1 unit left and 1 down, what do we get? We get first point here, 1 left, 1 down, second here, and 1 left, 1 down, third here, right? Joining these points, I get my parabola. Which is gx equals to x plus 1 whole square minus 1. Now, if we draw a line y equals to x, minus 1, 1, 0, 0, 1, 1. So those should be the points through which my line will go, right? So I'm just drawing y equals to x. Correct. If you now compare the graphs of our two functions, then you will find this point, see, it is symmetric. Do you see that? Same distance, correct? This is invariant, and this is also invariant, correct? Any other point, if you go from here, you come to this. So we will see that y equals to x reflects one graph on the other. So graphically, we can show that by restricting the domain for x greater than or equal to minus 1, we have actually shown that the two are inverse of each other. Now let's do algebraically. Okay, algebraically we can prove that both are inverse of each other if we do f of gx. If we calculate f of gx and we get x, then these are inverse of each other. And if we do g of fx and we get x, then it shows that these two are also inverse. So either way, if you work it out, then we can show that they are algebraically inverse of each other. Graphically, we have already shown that, right? And we are using restricted domain of x greater than or equal to minus 1 belongs to where? X belongs to real numbers, okay? So that's our domain. So let's do it, okay? Now these mathematical equations may go a bit longer, but okay, let's see what we get. Let's start with g of fx. G of fx, okay? Now what is g of fx equal to? G of fx. What is fx? Fx is equals to this, square root of x plus 1 minus 1, okay? So let me write that value. Square root of x plus 1 minus 1. Now, how is the g function defined? G function is, gx is, let me write here for convenience. What is fx equals to? Fx is square root of x plus 1 minus 1. And what is gx equals to? Gx is x plus 1 whole square minus 1. Okay? Now, first thing, when we say g of fx, then fx is square root x plus 1 minus 1. We brought this value here inside. Do you see that? So it is function of function. It's kind of complicated for grade 11 students, but makes more sense for grade 12 students. Well, but in any case, try to understand. You still can probably understand if you know function notation chapter very well. Let's go ahead with this. Now when we say g of this x, so this becomes our x. The function gx is defined like this. So here we'll replace x with that value. So I can write this g of this as, I'm just going to replace this x with, or rather here x with this, all this, correct? Correct. So let's do it. This is equal to square root of, the function is x, instead of x I'm going to write all which is there inside this. Do you see that? So it is square root of x plus 1 square root minus 1, and then after x we have plus 1. So already plus 1 and bracket close and square, bracket close square minus 1. Do you understand? G of this number. Let's think this is all as, let's consider this value as a, all this. Now basically what we are doing is, when we are calculating g of x, we are replacing this x with a. So x is a value, which is x plus 1 square root minus 1. So instead of this, we wrote x plus 1 square root minus 1, plus 1 square plus 1 square minus 1. So we got g of this function. Okay, I hope now it's absolutely clear. Okay, now here. Now when you open this, minus 1 plus 1 is 0. So we get square root of x plus 1 whole square minus 1. Now if you open this, we get square root, square will be just x plus 1. So we get x plus 1 minus 1, and this is equal to x. So we got g of fx as x. So we have proved that g and fx are inverse functions, right? Perfect. This is when x is greater than or equal to minus 1. Now we can do the second part also, that is f of gx. So let's do f of gx. We'll do it here. Now we'll do f of gx. It means what? F of, what is gx? Write down gx. Gx is this value. X plus 1 whole square minus 1 plus 1 whole square minus 1. Is it okay? X plus 1 whole square minus 1. Now, how is our function f defined? The function f is square root of x plus 1 minus 1. So, in this x, now what is our a value which we are going to replace? Now this is a. We'll replace this in our x, and we write this equal to, we'll write this equal to square root of, instead of x, we are writing all this. We are writing x plus 1 whole square minus 1. And after that, we have got plus 1. All this is within square root. And then minus 1. Do you get it? So this is f of gx. Now let's open. Now here, we know minus 1 plus 1 is 0. So we are left with square root of x plus 1 whole square minus 1. Now since x is greater than or equal to minus 1, this value is positive. Correct? Since this is positive, square root of this is equal to x plus 1. Square and square root of this. Okay? And then we get minus 1, which is equal to x. I think you should watch my video on square root of a square is actually absolute x, right? Now that absolute x is x if inside function is positive. So since we are taking x as greater than or equal to minus 1, we get x plus 1. If we would not have restricted the domain, and if x was less than minus 1, then this value would be minus of x plus 1, and then we will not get x. Let me just show you here. If, which is not our case, x was less than minus 1, then square root of x plus 1 whole square will be equal to minus of x plus 1, not plus of x plus 1. In that case, this function will be this minus 1 and will not get x. What we will get? Minus x minus 2. Then it is not an inverse function, correct? Do you get it? Okay, so in that case that will be minus of x minus 1 minus 1, which is minus x minus 2, not x. So anyway, since we restricted our domain to x greater than minus 1, we have shown that f of gx is equal to x. Okay. Now, you can always go back to the video, go through it once again, go through it a couple of times to understand each and every step and how we really did it. You may also like to review my video on square of square root a, the one on square of square root a, which is equals to absolute a, not just a, since you know what, 7 square root is actually equals to just the number 7, not minus 7. Do you see? So when it is negative, then what we do? We take negative of this value. We take negative of negative 7, which is 7. That's what it is. You will understand this point when you see the video a square over this. Anyway, we proved that these two functions are actually not inverse of each other, but if we restrict the domain to x greater than or equal to minus 1, then they are. F of gx is equal to x and g of fx is also equal to x. Okay? I hope that's a very interesting problem and you understand how to do it. Thank you.